Alright class, happy Thursday. We're finished with our power up. We have it flipped over onto the back side. We're going to solve some multi-step word problems. We're going to set them up just like we've been setting up some of our word problems in the past with a missing number, except for there's going to be two of them. Multi-step meaning two steps. Many mathematical problems take more than one step to solve. We have solved several kinds of two-step problems. For example, it takes two steps to take 10 minus 6 minus 3 in parentheses. We use two steps to convert feet and inches to just inches. We've also illustrated to solve fraction problems in two steps. The first step of a multi-step word problem often involves finding a number that does not appear in the problem. We then use the number we find to help us solve the problem. Here we got Wang. He's 5 years older than Robert. Robert is 3 years older than Sally, and Sally is 15. How old is Wang? And so we got two different groups of comparisons here. So who do we know? We know Sally, and Robert is older. So let's go ahead and put our first one here. We got Robert, and we got Sally. And we know that Sally is 15. That's an S for Sally. And we know the difference is 3. Now we can find Robert. We got the two small numbers, so we're going to add 15 plus 3, and that'll give us 18. So now we know Robert is 18. That's going to help us with our second step. Wang is 5 years older than Robert. So we got Robert, and we got Wang, and Wang is older. We already figured out that Robert is 18, and Wang is 5 years older. That's the difference. And now we got the two small ones, so we're going to add to find Wang's age. 18 plus 5 is 23. Now if you take a look how the book set it up, they set up the first one, but they didn't know anything. They set up the second one, and they knew two numbers. They could figure it here, and then when they had Robert, they figured here. Same exact way that we solved it. Number 2. Now we got Liam. Liam earns $16 for every hour he works. If he works for more than 8 hours on a given day, he earns 24. That's called time and a half for additional hour. Yesterday, Wayne worked for 10 hours. What was his income for the day? So we got 10 hours. We got 10 hours. And the normal pay is for 8 hours, and the overtime pay is for 2 hours. So 8 plus 2 is 10, so we're set there. Now we got to go ahead and go back. He gets $16 for the first 8 hours and 24 for the overtime hours. Now that we have it set up, we can multiply. 16 times 8. 8 times 6 is 48, carry 4. 8 times 1 is 8, plus 4 is 12. For the first normal day, he got $128. But the boss said, I need you for a little extra time. And he said, I will. So he got a little overtime here. 2 hours at $24 an hour. That's a pretty good deal. 2 times 4 is 8. And 2 times 2 is 4. Now you know what he earned for the first 8 hours and for the last 2. Isn't that crazy that for those last 2 he almost earned half as much as he did for the first 8? 16, carry 1. That is a good day's work. Wow. $176 he made in one day. That's because overtime pay is worth more than regular pay. That one is actually a 3-step problem if you think about it. You got to multiply twice and then add. All right, example number 3. Last night, Kiera studied for twice as long as Tempest, and Alonda studied for 10 minutes more than Kiera. Tempest studied for 40. So first of all, they want to give us a multiple choice here. Which expression can be used to find the minutes that Alonda studied? So Kiera studied for twice as long as Tempest, and Tempest studied for 40. So we need 2 times 40. There it is. Not there. There it is, not there. It's A or B. And then Alonda studied for 10 minutes more than Kiera. So Kiera would be 40 times 2, and Alonda would be plus 10. So then we can go and just work our way to figure these out, and our example number 3 answer would be A. Let's check out the lesson practice. The bus could carry 80 students. The 32 students from room 8 and the 29 students from room 12 got on the bus. How many more students can get on the bus? First, let's find the total number of students that got on the bus. 32 from room 8. Now, you don't have to add room 8. That's extra information. And 29 from room 12. This will give us our total number of students that are on the bus, 61. Now, the bus can hold 80 students. How many more students can get on? We would set up a subtraction problem to solve that. 10 minus 1 is 9, and 7 minus 6 is 1. 19 more students can get on the bus. That'd be a pretty small class, but you get one more class of 19 students on that bus. Two-step problem. First, you're going to add the students up and then subtract them from the total that can ride on the bus. All right, they got one more for us. We'll put it down here in our last box on the left. Mary Bella collected 37 aluminum cans for school, and her brother collected 21 cans. They decided that they would divide the cans evenly. So they put the cans into one big pile, and they made two equal piles. This is actually an average problem. Step 1, add. And step 2, divide by the number of numbers. We'll get to that in another lesson. So we got 58. It's pretty nice that it's even. So now we're going to divide it between the two siblings. 2 goes into 5 twice. 2 times 2 is 4. Subtract, you get 18. 2 goes into 18 9 times. Each child would get 29 cans. Two steps problems. Sometimes with two steps problems you got to read them carefully, especially if it's their double age thing. Work carefully through it. I like to read those problems twice, and then I set them up and then solve them. Stay tuned for the next video for a little help.